like to introduce Ignacio Robles, who works in the R&D department of civil engineering firm APIAXXI. Ignacio has very widespread experience in the construction sector. He's worked on projects as diverse as road transportation, renewable energy, and civil engineering. He's recently published a report, Lifecycle Analysis, Lifecycle Cost and Option Tools. Ignacio.
Thank you very much. So today I'm here to talk with you about a road construction use case. It's a little bit more down to the practical keyboard than the previous presentations. But before starting, I wanted to make 3 comments. One you already noticed. English is not my language, so please excuse me, and if I have any wrong spellings or how you say mistakes. Second, you're going to see some figures that are quite small in quantity and small in font size. Small in quantity, the reason is that the prices we deal with are based on square meter. So small differences, like a few cent differences in our budgets, provided that the road project was 97 kilometers long and quite wide, makes I could buy the house of my dreams with that difference. Small font size, because I don't intend you to read them. I'll color coded it, so you'll see cheap is in green, expensive is in red. That's all. Third comment, when I was asked to do this presentation, I was wondering, should I do a short presentation or should I do it like a little bit longer? A short presentation I thought would take me only 6 hours. And if I measure the usefulness of it by, like in a childish way, by the applauses, for example, I asked my friend Hannes here to clap 2 times at least. So this is a deterministic solution I have. I'm sure about these 2 claps, but thank you very much. If I would prepare a long presentation, then I would have to spend some more time, most likely like 20 hours of my time presenting everything to transmit all the information I wanted. But I'm not really sure I could do it faster. So it's very nice to have some probabilistic solutions here. And I doubt that with a long presentation, I might get not even applause, but some boos. So I might have -10 or the 2 deterministic solution, or it could be that some more people would applaud. So I have a wide range of possible outcomes. And then I was thinking, what about if I do something in between, something a little bit shorter than the long one, but then have some extra slides, say for the end of the presentation, just in case somebody has a question, and they can be useful. You see, this provides me some flexibility to my presentation, and I can model this. It's going to use, I'm going to use less hours, like 14 hours, could be less, could be more. And I have 2 stages, so if I have no questions, I still have my 2 claps from Hannes served there. But I have a condition that could happen, that I have some questions from you guys, and I could get the same type of response as in the long one. So I could run this. And I'm not expecting to get an answer of it. I mention all these comments just because I need you to think on this way before to understand our road case scenario. And by the way, you've been introduced to Select a Tool. So, road construction. Too many words. I like better this one. So, on a road construction project, there are many parts. It's quite complex. There are different structures. There are different drainage, bridges, everything. What we are focused here is on the pavement structure. So the objective is to get the correct slice of this sandwich you see in the right-hand side. And our engineers, what they have is they have to analyze the traffic that is currently in the area, that you have in the area, do a prognosis of this traffic evolution, analyze, of course, the soil, go to the standards, and do their design to make it the most optimal one. When analyzing the traffic, what they get is different categories of traffic, like T1 is between 2,000 and 800 heavy vehicles per day, for example. And in the soil, it's pretty much the same. You have E1, E2, E3, and it's basically what quality of the base foundations you have for the road. E3 being the expensive one, the good one, E1 the cheap one. And then you go to the standards, and it's a mess. It's it's complicated. You have a lot to choose from. But you go with your substrate, you have your foundation, and you have your objective on the traffic category from the top, and then you have certain options that you have to select from. For example, in this type of zooming in, you can see that there are certain options that are flexible and others are not. If I create a road structure with an E2 road base. If I want to, this is serving a T1 type of traffic. If I want to change it to a T0 type of traffic, because our traffic is growing and needs to be upgraded, I need to demolish all the road and rebuild it again. But if I had already constructed from the beginning a T1 traffic type, but with an E3 road base, I only have to grow the top part of it. So it's much more easy to upgrade the road. So this type of considerations is what we are trying to explain here. Our use case. So my company did this road project for a real road in Catalonia. The initial conditions were a certain road base type and type of traffic category T2 jumping to T1 in certain sections. And the engineers gave the solution to the administration with all the project. The solution was E3, 132, whatever. The question is why, and is it the best solution? Linking to what William was saying about the uncertainty, our traffic department does these studies that measure the traffic growth based on the history of the area and the measurements they do, but that's until that moment. Afterwards, you have a growth period. This is when the road is built. The people are changing their habits and they're starting to use this new road. And this is increasing quite a lot. And then after that is the natural increase. So in the traffic prognosis done for this project, you would have three different growths, like the pessimistic, the most likely, and the optimistic vision of it. They also study the section esplanade, the substrate I was talking about, and they decided for that solution. What was taken into account was the price of not only the different sections, but the price of upgrading from one section to another, of the different possibilities. Also, the initial construction cost, the operation and maintenance cost, and the expansion costs. And this is what I was telling you about the color coding. So with a discount rate of 6% and upgrading based on the traffic analysis that they did, they thought that for the worst case sections, it was going to be needed to upgrade it in year 4, 5, and 9. for those pessimistic, most likely, and optimistic growth rates. And you would see that the selection they did was reasonable, because they selected just to construct a simple solution, the 1, 3, 2, that's in the middle one in the right. It's quite green, not too red, but things changed. Of course, the administration is now telling us why this road is not constructed, but we all know that this, by the way, was happening in 2009. The road should be finished this year. The road is not being constructed. We can only speculate why it's not the case, but what we did is try, of course, it's probably because the administration doesn't have the finance right now. But we can ask ourselves as an engineering group, is the design correct for the conditions we have nowadays? And the thing is, we looked a few months ago again to the discount rate, and the discount rate for our sector in our country has risen quite a lot. So from a 6%, we went up to a 10.6%. And interesting enough, also there is this road is not a national road, but there is a law affecting national roads nowadays that they call the deficiency law, and the government enforced engineering companies to use certain traffic growth rates, and these are much lower than what was used in the initial study. So if we link to these two new input data, and we again do the analysis, all of a sudden we see that the outcome is not straightforward anymore. It's not the same one as we provided the administration with 3 years ago. In fact, the flexible options, you see these ones over here start making sense. You have switching times that is not anymore in the short period, it's a little bit longer, from 15 or 20 years. And we wanted to try to understand this with the Selecta tool. So how do we do it? Well, you've seen already a little presentation about Selecta. You just take your design, what your engineers give you for the budget, and you start inputting the information. You can get the information from the different data banks for the prices, for the environmental impacts. You can use also mathematical expressions. We needed quite a lot for that, of those. And each of our alternatives can be modeled, and you can see, for example, to debug our model, we have these little charts in the right-hand side, which we just run one simulation run, and you see where the costs are. This is only a cost, sorry. The costs are imputed. Where the maintenance is happening, and where the extraordinary rehabilitation costs are happening in time. These are little tiny histograms. Our model is a little bit more complicated, and this was done without the databases. When the databases came into hand, we got very happy about it, so we started growing the model, and this is our latest version. It's 3 stage 1. Some of the initial results that we have, we have the data in table formats, and what I like most is this type of graphs in which you can mix whatever units you have. Like in the beginning, I mixed hours on claps. You can use euros and CO2 equivalent, and we have the explanation of which one could be more convenient for your project. You have also box plot charts, and if you increase the traffic uncertainty, I'm not sure if it's the correct one, what the government is doing. What I get is this type of results that are quite helpful. Trying to, the little blobs there are trying to give you an idea of the uncertainty on each of the axes that you have. And finally, what we did is, once you have the model there, it's very easy just to repeat it with different values, and this is what we get excited about. So we changed from a 6% discount rate to a 10.6% discount rate, and the question is, what's going to happen in the future? So we did a sensitivity analysis, and we went from 4 to 14, and also we've seen that the traffic growth had a big uncertainty. So we made it change from 1.3% to a 4.3%, but also the uncertainty of it was increasing. And what we found out was that the initial design that our civil engineers chose was based on a low discount rate and very high traffic growth rates. So what they were doing, in fact, was perhaps over-investing, perhaps playing it safe. You know, engineers just, I don't want this to fall apart, so just put an extra percentage. It's quite typical from them. So they were in the high spec range. And what we got when we analyzed the new figures, we got a solution in the lowest spec range for a very high discount rate, which is due to many factors, one of them the risk premium of the country, etc. And also, economy has gone much lower, traffic growth also stalled, so very high rates, very small traffic growth rates gives us the optimal selection of a lowest spec solution. What we have is a tool that is not, what was mentioned, is not the crystal ball trying to give us an insight of the future, but we have a tool that helps us understand the decisions that we have to make today. It's capable of doing the deterministic part, it's capable of doing the probabilistic part, it's capable of helping us to model real options, the flexibility, the cost of these flexibility options. On top of that, doing nothing else, that's the added bonus for on my side, is that we have the LCA included in it. So, questions?
Thank you. Ignacio, thank you ever so much for that. I think you did a great job of condensing what was a 20-hour presentation into, I think, something less than 30 minutes. So thank you for that. Your English was perfect, by the way, so I think far better than if I tried to speak in Spanish, I think. So that wouldn't be difficult then. You've identified, at least demonstrated, a case study using the selector tool of load construction types. And I think, to me, you showed quite clearly the impact of assumptions associated with discount rate and traffic forecasts on the outcome. So it's a very helpful example of how a life cycle costing stroke assessment tool can be used.
You produced a model for a road that didn't get built. Have you any indication as to whether the decisions that you took with that whole life costing model actually influenced that decision in the first place?
Okay, first a comment on your question. We didn't build a model of a road that was not built. We did a model of the road construction. I mean, this same model is going to be useful for the company in the next roads that we have to construct. Is that they have to be under the same standards. And no, I don't think the administration decision was based on these studies. But I can only speculate on that. Sorry.
I apologise for my English. For me, it's pretty much like the last presentation, really. It's about how to construct an analytical solution for making a decision today. And then keep referring to that as time changes and growth occurs or shrinkage occurs. It's today's thinking for today's problem, isn't it?
Yes, indeed. Certainly. I mean, and linking with the comment I mentioned before, the good thing about having modeling is that you can update it every day if you want, and run it again, and thousands of simulations, and get the updated answer of whether your decisions are optimal or not.
And for me, hopefully, this could be used by the clients directly who are responsible for the road system once it's been constructed by the professionals. Once the tool's been constructed by the professionals, it can be used by the administrative.
Or the operations and maintenance department, or indeed. The procedure is there for everybody.
Ignacio, in terms of the outputs from the Select tool, they look to me very, very clear and very powerful tools to convince the client that they should go down one route or another, or at least to encourage discussion about the particular options. Do you believe that if the tool's used in the future, it will be understood by the end client and they will act on it, or do you think there are other factors which the client will consider?
I know nothing about politics or marketing.
Okay. But politics and marketing dominate all of that, and I suspect is the answer to that. And the other question is to do with the practical implementation. You've clearly had to insert an awful lot of data into the model about the embodied carbon associated with materials and such like. What confidence do you have that those numbers are right, and to what extent does it matter that they're not entirely accurate?
That's the nice thing about the sensitivity analysis, that it tells you how the output is changing depending on how your input is variable, how variable it is. What I feel is that with this type of procedures, these type of tools, what you have is the freedom to, if you suspect something might change, put drop the certainty there. If you have analyzed your risks and you feel that the petrol prices are going to change, or etc. I mean, this model, it's quite simple. It could be much more complicated. You know, the asphalts, the prices depend on the petrol side. So I'd love to go back to it and add this uncertainty to it. It's how you deal with it, and how much time, of course, you want to spend for a certain project.
Okay, thank you. Question
here. The example here is that it's a fairly simple tool that you can interrogate over time. The interesting thing here is that if you remodel that, assuming they are going to build your road, and I hope they do, that if the transport increasing goes up from 10 to 20,000 vehicles a day, and you'd expect it to go up from 10 to 15, then you can remodel and work it out. Which brings us actually very closely back to the first question, I think, of the day, which is how long does an entry system last when it's getting beaten about by people coming in and out of a building, or how long will the lift survive? Both of these factors are dependent on the use of the building or the use of what's going on. And I think that's where it comes back to our own professional bodies, our own organisations, and perhaps with support from BRE and BISIA and others, that actually the information to do with your road is only of interest to road people. The interest to do with lifts is only interest to people dealing with lifts. And entry systems is dependent on the people using those. But the answers are available now. It's just that the people who then want to extract that information don't have access to it. So it's down to our own organisations to collate that information and put it together so the rest of us can make best use of it. And I think that's a fundamental that must come out of this kind of environment.
Okay, thank you for that.
So sorry, not a question, but a statement I think that we all need to take on board.
Totally agree.
Thank you. Ignacio, I just wondered if you could comment on your final analysis, when you'd got your two-dimensional output of your variables for traffic growth and your variables for discount rate, showed 3 different specifications for the road design. But it's from that you've actually got 6 that were ultimately to be chosen from. And so I suppose my question is there as much importance to the user or to the end user in actually knowing which of their available decisions are not even on the chart as knowing which of the 3 might be kind of to be chosen between?
I'm not sure if I follow, but I'm pretty sure that falls on who has the criteria of decision.
Yeah.
I mean, who is the one that is going to decide what discount rate you have to apply and why? And are you interested on, if it's not road construction, whatever, on a different solution or not?
Yeah.
I don't know if I've answered your doubt.
Okay. No, I think I was looking at the range of specifications you've got at the bottom of your chart, and you've got 6 different upgrade scenarios and 6 different colours there. But only 3 of them.
Where are the 3 that are missing?
Yes, yes.
Probably should extend the uncertainty to find them somewhere in the
Okay, so they're
parts, right?
further away from where we're looking.
Yes.
Okay, thank you.
It could happen also that they're just not the optimal solution, because what I applied here was my criteria of choosing the most economical LCC solution at the end of the day. And I'm worried because I'm talking something against what Andy was saying in the morning. But yeah, my manager is like always pushing to get the most economical solution towards the customer also. It's my criteria following.
Any further questions? Bring it to a close at that point. Okay. Well, thank you very much. Okay, thank you.